Okay, can you see my slide right now, method of sections?
Yes.
Okay,
Yes.
thank you. Okay, right now, let us have a, because in this, this course, on this structure, the trust analysis, we don't specify that methods that you must use in the trust analysis. Okay, but here I introduce you these two very common method for the trust analysis. In our last class, I've shared with you on the method of joints. Okay, so today I'm going to share with you how are we going to analyze the trust using this method of sections. If you look at the word section, meaning that we are going to cut section, okay, for from this given structure. Okay, so let's have a look. So this is the some of the this description, okay, on the method of section. Maybe we can highlight, okay, important point, okay, or information here. Okay, so if you can see the first one, if the forces in only a few members of the trust are to be found, and the method of section generally provide the most direct methods of obtaining these forces. This also means you don't need to determine all the forces, okay, only a few that you require. Okay, therefore you can choose this method because this method of section will be a direct method to solve for all these forces. Okay, instead of you go joint by joint. Okay, and then this method for the second one, this method consists of passing an imaginary section through the truss, then cutting it into two parts. So imagine you have this truss, okay, and you cut it into two. Okay, so this will be part one, this will be part two. So you need to do that in order for you to prepare for the analysis. Okay, the third one, provide the entire truss is in equilibrium. Each of the two parts must also be in equilibrium. So we always talk about equilibrium. So meaning that once we cut into these two parts, okay, so part one here, the truss, and part two, when you analyze it, both of these 1 and 2 must be in equilibrium. So what is the meaning of equilibrium? We talk about this. Okay, summation fx that we have mentioned earlier, summation fx, summation fy, and summation moment. Okay, in 2D structure. Okay, if in 3D you have 6 equations, equilibrium equations. So now we are going to use these equations, okay, to make sure it's all equal to 0. Okay, so then next, a decision must be made as how to cut the truss. So the challenge or maybe something that you need to make a decision is where shall I cut the truss so that I can get all these member forces that I wish to obtain in one cut. Okay, so for example, if you have this truss, you might thought of cutting in this way. Okay, or you might thought of cutting in this way. Okay, so you need to make a decision. Okay, so we will go to one example later. So in general, the last statement, the section should pass through not more than 3 members. Okay, there is some guideline or tips here, because if more than that, it will be, we just cannot solve it, because we have these 3 equilibrium equations that we use. If more than that, there will be too much equation of the unknowns, okay, that we are unable to solve it. So let's try on one of explanation for an example. So for example, this problem, am I too fast? Let me check. Sorry, wait. my class. Okay, now we have 17, including me. Okay, so let us continue. Okay, can you see my example 2 here?
Yes.
Okay, thank you. So now we just want to determine the axial force for FE. Sorry, FE, FC, and BC. We don't want to determine all of them. So now you need to decide where is the EC, where is the FC, and where is the BC. So now I try to, this is BC, this is FC, this is FE. Okay, so maybe you can, just by observation, you know where to cut. Okay, because you just want these 3 members. What if it is at AF, AC, and CD? Okay, so you can imagine that. So now we want to cut a section. Okay, so I would like to show you the next this. So this is the section AA that being planned. Okay, because this section AA has cut through all the member. And remember just now we said here, in general, this section shall not be more than 3 members. Okay, so here we have cut through the 3 members, not more than that. So there should be no problem. Okay, once you have cut through, you can start to get your support reaction. Okay, so at this step, this slides we will show you how to get the support reaction. Okay, here AX, AY, you may put in the arrow as you assume. Okay, any direction. If horizontal, you want to go to the left or go to right, it's up to you. There is no problem as a start. Okay, so then you will base on what you assume here to establish the equations based on the equilibrium equations. Okay, so you have established the first one based on summation moment, and importantly, you need to assume a direction. Which one is your positive sign? Okay, let's say you have assumed the clockwise is positive. Okay, so then next you need to now we haven't go into the cut sections, analyzing the section yet. We just want to get the support reaction. So here maybe you can put overall structure. Now you are analyzing overall structure. You can put on your notes now. So now you get, referring MA equal to 0. Okay, so AX, AY will not be considered in these equations. So the one that will be included will be 1002, 400, and the dy. At this moment, dy is still unknown. Okay, so now the 1200, to get the moments, remember we have the force multiply the distance. Okay, so the force is 1002 and the distance is 8 meter. Okay, now you have 1002 multiply the 8 meter. Okay, why this is positive here for this force? Because this force is acting, when acting at A, it is, if you can see that, it is clockwise. Okay, let's move to 400. 400, this distance, just to remind you, it shall be perpendicular. Perpendicular to the force. Okay, maybe you can, if you have forgotten about this. Okay, so therefore this 400 kilonewton, if measured to A, the perpendicular distance will be 3 meter. Okay, therefore now if you're looking at 400 loading, you shall multiply the 3 meter. Okay, so and the distance here now, you are with the loads, you are acting in this direction. So it's still positive here. And then we go to dy, the last one. Okay, dy is 900 and the distance perpendicular to A, to measure to A, is this 4 times 3. So 12. And why this is negative? This is because this force acting counterclockwise, okay, to the A. Therefore, you have negative. So you can solve these equations very easily because there is only one unknown. Okay, so you get the dy directly. Okay, so now when you have solved for one of the unknown, that will be very easy. Okay. Yeah, before I go too far, before you start analyzing this, you should make sure that this is a determinate or indeterminate system. Okay, so if you still remember, we have D equal to M plus R minus 2J. Okay, for the truss, to classify the determinacy of the truss. So maybe we can have a very quick one to check. Okay, so M will be the member. Now we have 1, 2, 3, 4, 5, 6, 7, and 8. Okay, we have 8 member, and we have 3 reaction, and we have joint 1, 2, 3, 4, 5, 6. Am I right? Why this sounds incorrect here?
Doktor, member 6. 9.
9. Sekejap, mana saya tertinggal. Oops, it's here. Thank you
MB.
very much. So this is 9. Okay, thank you. So 9 plus 3 minus this is 0. So what does this mean? This is the determinate, statically determinate truss. So therefore, you can use the summation, the 3 equilibrium equation to solve all your support reaction, which you are doing it right now. Okay, so now we can forward to summation Fy. Now you got the dy. Okay, so I think this is just too messy. I need to discuss this and then go back. Okay, so now from here, I'm going to move a bit faster. So now Fy, we talk about the vertical force. We have to identify this is the vertical force, and vertical force. So summing this up, Ay plus 900 minus is because this is going down. Okay, equal to 0. So you can solve Ay. And similarly for summation Fx, now you're looking at the horizontal direction. So you need to identify which will be included in your equation. This is horizontal, Ax. This is horizontal, 400. Okay, so negative Ax because going to the left, and positive because going to the right is what you have assumed. So you can solve for your Ax. Okay, so now you can maybe this few class I'm a bit slow on the support reaction. Okay, because this is very important. If the support reaction you have obtained wrongly, the remaining answer will not, it will be incorrect. Okay, now we go to the section. Just now we have cut the section AA. Okay, to draw it, you will analyze either part A, I call this part A, part 1 maybe, and this is part 2. Okay, you can analyze either part. Okay, in this example, we show this part 1. Okay, you need to make sure this part 1 is in equilibrium. Okay, so now if you look at that, we have FFE, FFC, FBC. Why this naming where is it come from? It will be coming from the member force itself. So this one is FE. Okay, because from F to E, and this is FC. Okay, this is BC. Okay, so this is how you name it. Okay, and then you need to put in all the information, all the forces. If there is external force, you need to include it. Okay, all the forces that should be in this system. Okay, then you can apply the equilibrium equation. Either you use moment, either you use Fx, and either you use Fy. But in this case, they use moment and summation Fy, yeah, this problem can be solved. Okay. And then one more thing is about this trigonometry, just a revision back. Okay, if you have a triangle like this, okay, so you have a theta, okay, you have this perpendicular, I mean, sorry, this is, what is it? Opposite, okay, opposite side, okay, and you have this side, okay, close side. Okay, so now if sine theta, you'll be looking at the opposite side divided by this hypotenuse. This is the hypotenuse. Oops. Okay, the cos theta, you are looking at the closer side. Okay, 4 with the divided by the hypotenuse. And the tangent theta is equal to 3 divided by 4. Okay, so if you have this, no problem. Okay, then there will be more easier for you later. Okay, so next, so now we look at this statement. I'm going to go maybe 1 or 2 only here. So now it takes summation MC here. Okay. Summation MC means that it try to take all the maybe you can help me to put in your notes here. This is looking at the not overall here, part 1 system. Okay, they are looking at part 1 system. Okay, now in the part 1 system, to get MC equal to 0, summation MC equal to 0, so we will have this 300, we have a 400, and we have a FFE. So maybe it tells you why you need to start with the MC, because it want to eliminate more unknowns and remain only one FF, I mean the FE force here. Okay, so now from here you can solve the FE directly. Okay, now you get the negative here, meaning that it's compressive. Okay, this one also I need to remind you again. Okay, it depends on our tips yesterday. Remember, yesterday there is one tips. Is that yesterday? Not yesterday. Monday. Okay, there is one tips in the joint analysis where you have to assume any unknown forces, okay, to go out from the joint. Make it as tension first. Okay, so if you follow these tips, okay, just like what's shown in this example, FFE is going out from F. Okay, FFC is also arrow going out from F. B also going out from, I mean, FBC is also going out from this joint B. Therefore, all of this is tension. Therefore, when you get the answer is negative, you can tell this force is in compression. Okay, but if you do not follow these tips, do check. Okay, do check whether this negative, what is the meaning of this negative. Okay, so next, it takes a moment at F equal to 0. So now why it takes moment at F equal to 0? Because it want to eliminate this FFC as the unknown, and it don't want to calculate this FFE. So now remaining in this equation will be FBC only. Okay, therefore it can solve directly FBC from this, summation MF itself. Okay, then you have a, almost there. So it's left only FC. So you can use any method, summation FX, summation FY, or even summation moment. To get this summation moment at other joints to get this force FC. Okay, but now in this case they use the summation Fy. So here, be careful, summation Fy equal to 0. So we get 300 here, and AX is not vertical. And what else is vertical? Oh, only FFC. So you need to resolve the FFC into vertical force. So when you are resolve these forces away from this angle, away, you resolve into this vertical, then you use sine theta. Okay, that you already get the sine theta here. So you get your FFC. Okay, so maybe I'm just explain in a detailed way, but I hope from this very fundamental, you can apply it into a more complicated truss. Okay, so now you get all the forces here. Okay, so for example, FFE and only FFE is negative at 100 and the rest is positive tension. So this is how you do on this using the method of section. Any question for me? Class, do you have any question for me?
No.
Okay, am I talking too fast?
Okay.
No. No.
Let me see our class right now. We still have 4 more to come. Huh? Okay, so if you notice that your friend is not here, please ask them to join. Okay, so now I would like to go to the U future and tell you how to click on your attendance. Okay, so now let me show you my view. Okay, I get this feature from the online class. I do not know how your interface look like. Okay, but this is what I've seen. Okay, so you shall go to this U future, okay, to click on your attendance. Okay, so I see that we still have Afiq is not around with us, is it? Muhammad Afiq, are you here?
Yes, madam.
Maybe you can go and click your attendance right now. Muhammad Amir,
Okay.
are you here? And Nu Amelia, are you here now with me?
Yes, madam.
Yeah, please click it. If not, you will be you will be this red dot here. Okay, maybe I will show on the 2B. Okay, where is the 2B? Wait, 2B. Oops, there are 4 only. Ali, Imran, are you here in the class? And Muhammad Daniel, Irfan? Maybe they are not coming. Who knows these 2 friends? Please text them and make sure they come to the class now. Okay. So if you have, if you're okay, I'm going to start my today plans lecture. Okay, it will be on also on the truss analysis, but to determine the deformation. Okay, can I continue?
Yes.
Yes.
Okay, so be patient. Okay, now this is what I have to share with you. I shall share in such. Should I share? Can you see my these slides?
Yes, madam.
Virtual work
Yes,
method.
madam.
Okay, virtual work method. Okay, so I'll start right now and then give you some time to work on a question. Okay, so maybe please stop me if I'm just talking too fast. Okay, so from this lesson, today lesson, you shall be able to apply the virtual work method, okay, to determine the deflection of the truss. Okay, so This is a reading slides. I would like you to go through these reading slides on what is these methods about. Okay, who developed this method, and then what is the concept behind. Okay, basically, just to pause these slides. Basically, this is the very useful method. Okay, to solve for many deformation of the structures, and it use actually this work done. Okay, external force. Okay, that is equal to the internal work done. Okay, they use this concept. Okay, how much the work done in at external, it should be reflect in the internal. Okay, so this is the very important concept, but please read through these slides. Okay, so this is more explanation on that, and with the graphical to tell you what is this about. Okay, the principle of virtual work. Okay, so I'm going to pause again these slides and talking about this equation. How to get this equation? Okay, because we are going to use this equation to determine the deflection in our next example. Okay, this equation is actually come from, if you still remember your Hooke's law, stress is equal to the force divided by area. Okay, the force N is the axial force and the A is the cross-sectional area. Okay, then the strength. The strength is the, should be something like that. So this is the axial force and this is the area, cross-sectional area. Okay, when you have this axial force for, let's say, is a the member is in tension, so you should have a elongation. So this is the original length. Okay, original length, and this is the formation that happened. Okay, this is the delta. Okay, so now the strength also means this delta divided by the length. Okay, we come back to one more equations, not written here. May you add here? There is one more equation. Is the stress is actually having a relationship with this strength. Okay, with these slopes of Young modulus E. Okay, so if you look at the stress and the strength here, we are going to substitute the equation 1 and equation 2 into this equation number 3, let's say. Okay, then you will form here. Okay, let's see, N over A is the stress, right? So this is the N over A, stress. And the strength is delta over L. Strength is here, delta over L. And we have the E here. So now, if you have rearrange, okay, the elements in this equation to make sure you just want to determine the deflection, okay, where you move the E to the other side and the L to the other side, it forms this equation. And this equation will be used to find the deflection of your structure. Okay, you need to remember this because it will not be given to you in the test. So next, okay. So now we are looking at this. Okay, if you want to find the deflection, you use this equation. So now I'm going to show you in details on how to determine the deflection of the truss. If you look at this equation, why this is quite different from here, right? Okay, because this is one of the procedure, okay, in this virtual work method, okay, where you need to actually have to analyze two different systems. Okay, one is the real system and one is the virtual imaginary system. So this N is the force, right? The axial force. So this N is from the real situation. So you are analyzing the real truss, okay, with the real force, with the everything in real, okay, in your for your structure. But this N is from the virtual, the imaginary. How to get this imaginary, I will show you later. But you'll be deal with this virtual unit load. You're going to put an imaginary load to where you want to determine the deflection. Okay, so and A and E will be the, as I've mentioned earlier. So, but this truss having more deflection, not I should not say more deflection. The deflection will be affected if this truss are subjected to these two conditions. One is due to this temperature change, and another one is due to fabrication error. Okay, this temperature change and fabrication error is not that significant in the other structure like beam and frames. Okay, but it from the examples later, I will show you that it's that there will be obvious, okay, obvious changes. Okay, so what you will expect here, in addition to the displacement due to the loading just now, the deformation, first of all, you need to determine this, the deformation due to the loading in the real structure. But if your truss have additional conditions like subjected to truss, subjected to temperature, then you need to add the deflection just now from the loading. You need to add with this one. Okay, this you need to look at the inputs here. This N is the axial force from the virtual structure. And then this alpha is the coefficient of thermal expansion. Okay, and this delta T is the change in temperature. If it is increased temperature, we have a positive value. Okay, for increased temperature. If you have a decreased temperature, you get a negative. What is this positive and negative about? So let's say now your truss is subjected to this, let's say the temperature of 25 degrees Celsius. Okay, but in maybe in other country, it go down. The environment go down to 10 degrees Celsius. So the delta T here is the changes. Okay, the current, this is current. Okay, this is new. Okay, so it will be 25 minus 10. It will be 10 minus 25. Okay, so it will be negative 15 because this is a reduced. Okay, the reduced degree of temperature. Okay, so this is how you get the delta T is the difference between the new and the current. Okay, if it is decreased, you put a negative. If it is increased, you put a positive. Okay, how about the fabrication error? Fabrication error, still you have this N. The N is the axial load from the axial force from the virtual structure. Delta L will be the difference in length. Okay, so for example, you actually, the truss is having 3 meters. But after construction, it become 3.001, let's say, meter. So is there any changes? We are going to check later. Okay, so using this, okay, plus, you need to plus, okay. So without going more on this, I'm going to directly show you on an example. Okay. So let's start with a very simple 3 members truss. Okay. So what is the aim of the example? Is we want to determine the vertical displacement. okay, vertical displacement of joint C. Okay, so it's given to you this set of area, cross-sectional area and Young modulus. Okay, so now we want to plan our solution using the virtual work method. So first of all, okay, we need to tackle this. We know that the deflection is found from NL over AE. Okay, we are going to produce the N first. How to produce the N? Okay, so the N, you need to understand that it is the real member force. Okay, it is negative when it is in compression. It is positive when it is in tension. Okay, so then how to get the N? You need to idealize the real structure. Okay, with what method is up to you, but for the real structure. What is the real structure then? The real structure is the truss that's subjected to the real force. Okay, so we need to include all these forces, the real forces, real external forces inside. So reloadings. So now we are going to create this. It is not correct. It is just similar like what in the real structure. This is the real structure. Okay, you just need to analyze this real structure in the problem. Then you get the N. Okay. So you start with the finding the support reaction. Okay. This one you need to go through. Okay. Here, don't forget about this external load. Okay. And then in this case, we don't have any fabrication error and we don't have any temperature change. Okay, so now after you determine the support reactions, okay, you solve for the forces. Okay, by joint. Okay, joint A, joint B. Okay, done. Okay, class. Do you need me to explain in detail this joint A? Hello, class.
No, no need.
It's okay, it's okay.
It's okay. Okay, yeah, so I'm going to continue with this. Okay, so this has been explained earlier. Okay, joint A, how to solve it, joint B. Then after all, you get all these member forces. Okay, so these member forces you may put in to the system. Okay, if it is compression, it should be actually in this direction. Okay, if tension, it should be going out from the joint. Okay, so next, we have sorted out with the big N. Now we have to come with this analysis for the small n. Okay, for the small n is come from the virtual structure. Okay, this virtual structure similar to the big N. If negative, we put a compression. If positive, it is a tension. Okay, and we need to get the N from the virtual structure. Okay, what is the virtual structure here? The virtual structure is you need to create an imaginary truss. You remove, okay, all the external loads, and then you apply 1 kilonewton unit virtual load. Okay, it can be Newton, it can be kilonewton, it can be, because this is imaginary. Okay, so 1 unit virtual load to the location where you want to determine the displacement. Just now where we want to determine the displacement, class? Are you with me? Do you have the notes with you?
Yes, yes.
So where is our concern right now? Where is the displacement that we want to find? Anyone with the notes can answer?
Horizontal.
Horizontal? At where? Okay.
Vertical displacement of joint C.
Thank you very much. So I have to flash back here. So we are actually determining the vertical displacement at joint C. So what you need to do is how to create the virtual structure from this real structure. Number one is
Remove all external load.
thank you very much. So now we remove, we shall not put in this 4 kilonewton. And the second one, this one is remove the external load. The second one, anyone can help?
Apply 1 kilonewton.
Yeah, apply 1 unit load. Maybe in this case, we put 1 kilonewton to the joint.
C.
Yeah, to the way you want to find the displacement, it will be joint C. What is the direction? Direction of the 1 kilonewton?
Vertical.
Yeah, very good. If you want to determine the vertical displacement, we put vertical virtual load. Okay, 1 kilonewton unit here. Can I put going up 1 kilonewton? Can I do so?
Yes.
Yes. Okay, this assumption is by you. Okay, we will not know this assumption is correct or not until you solve the deflection value. If the deflection value is positive, meaning that your assumption direction is correct, is as what you have assumed. Okay, but if it is negative, meaning that it is actually not the opposite direction that from what you have assumed. Okay, let's go. Okay, so this is how you do, this is your virtual structure right now. Again, you start with this, either you want the joint method, section method, okay? So you solve for this truss, okay? And this is your small n, okay? But now we want to apply this big N, small n, L over AE, right? But this summation means that for all the member. So it will be more easier for you to use the tabular form. Okay, therefore you can start with this. Okay, putting in how many member classified A, B, A, C, C, B, and what is the N for each of these member. Okay, for example, AB is 0.667. Okay, and big N is 2. Okay, be careful on this negative or positive. Okay, if compression, you should put negative here. And the length, you need to look at the dimension of the truss to put in the length. Okay, then we start with this calculation of this NL over AE. Since this AE is actually a constant, so we may calculate this, include this AE later, not here. If not, it will be just time consuming unless you are working on the Excel. Okay, so are you able to calculate this N and L? This N and L means that this multiply L. Okay, once you get this value, and then you have a summation. Okay, so next you try to put it in this virtual equations. Okay, so if you are given, if the problems give you the A and E value, make sure you have put the units correctly. Okay, so you shall not have Newton at the top, kilonewton at the bottom. Okay, make sure you have the same unit at the top part and at the bottom of the fraction. Okay, then you can get your answer here, deltas C. If you want to name your this delta, why this is CV, C means the joint, the location. Okay, V means the direction. Or you have your own more creative and good symbol. Also, okay, no problem. Okay, as long as I can understand. Okay, but now you look at this positive, right? And this is going down. This is what I have meant just now. Okay, because in your virtual work just now, you have put this assumption 1 kilonewton is going down, meaning that if you get a positive value here, your assumption direction is correct. This joint is actually moving down after you apply the loads. But if you get a negative, meaning that the opposite way. Okay. I want to continue with 2 more slides here. Okay, before you are being given a tutorial question. Okay, so this one is just to show you the same example, same problem, but now with some effect. Okay, what is the effect? One is the due to temperature change, and another one due to fabrication error. Okay, remember we have additional equations, okay, to sum up in addition for this special case. Okay, so let's try. Okay, due to the load just now, okay, we have solved the deflection. This is the deflection due to the load just now. If the load here in this example 2, there is no change, still 4 kilonewton, meaning that the deflection due to the load we can maintain as 0.133 mm. Okay, at C, this vertical displacement at C. And then now there is a condition due to temperature change. Okay, we have 2 members here, member BC and member AB. Okay, so this is the equations that due to the temperature change. Okay, we need to sum up all the axial force for the related member only. Which member related? Member BC and also member AB only. Okay, so that is why here, if you look at the equations, NBC is included. NBC, where you get it, is from the virtual axial force, from the virtual structure. Okay, and NAB is from NAB. Okay, now we have to continue with this coefficient of thermal expansion. Okay, it's given to you. Okay, so you can put it in the equation and the delta T now. Okay, they said that this is increase of 25. So we have a positive 25. Okay, this is decrease. AB is decreased by 10. So this is negative 10. Okay, and the length of the member. Okay, just include the length from the member. Okay, then you get a deflection. Okay, so if you realize, if you can see the deflection here, you get a negative 1.7 mm. Then check with this loading, due to the system due to the loading 4 kilonewton, it deflect only 0.133. But due to this temperature, it added, some deflection here, okay, in the opposite way, 1.7 mm. Therefore, these changes is considered significant and need to be considered in the truss analysis. Okay, let's move on fabrication error. How to use this formula? Okay, this formula is still N. Look at which member has affected. So now this member AC only have fabrication error. The rest no. Okay, so we can go to find where is member AC. Still from here. Okay, then the L. the delta L, the change, the difference of the length, change in length. So the change in length is negative 0.005 meter because it is shortened, okay, fabricated shorter, okay, than the initial. So you use a negative. If it is longer than what it is meant to be, so it is positive, okay. So now you get this 4.17 mm. So you need to sum up all these factors. One is due to loading, due to temperature change, due to fabrication error, and this will be the final 2.6 mm downward, okay, the vertical displacement. All right, do you have any question for me before we proceed to the tutorial session?
No.
No? Okay. We still have only 17 here. Okay, I shall share my screen right now. Okay, class. I have to remind all again that our lecture will be following the this scheduled timetable provided by the faculty. Okay, so unless there is an announcement on these changes, we will just follow. Okay, so you can get the links. Okay, if you haven't get my links to the meetings, please remind me. Okay, I hope to get to you the correct link next round. Okay, so and then now I'm showing the U future because I want to let you know that for your group 2A and 2B, in the I discuss, okay, please visit the I discuss every week. Okay, so I will post some documents for additional learning, okay, besides of our this face-to-face meeting. Okay, so if I click on this week 1, okay, every week you need to participate in this I discuss. Okay, instruction will be given to you here. Okay, so this is the one that I posted yesterday. Okay, so in addition to the online meeting in Microsoft Teams, students are also required this week. Please redo the exercises I posted here, okay, through the video. So you can go through the step by step, or if you are you have no problem at all, you can just solve it. Okay, so these 2 exercises, okay, through the video, and then do the exercises, okay, from the one that I post here, week 1A, week 1B, and then C is please write something in this I discuss. Okay, at least 2 posts. Okay, so here I got you to answer these 2 questions. Okay, if you think that these exercises are just too simple for you, okay, then you can go to this advanced learning, okay, and you want to, because you are so hardworking, okay, so you want to learn more, okay, then this link will be very useful, okay. It is strongly recommend to you because there is a lot of question and with the answer, okay, so you can have a try on this. Okay, we go back to our tutorial right now. I'm going to show you the tutorial now. Okay, I will stop the recording as well now. Okay, so before I go to this, I would like to ask one more about this team. I see most of you already have the, Microsoft Team, okay, and you join in with your this name, your ID name, okay. May I know that you can see this post in your Microsoft Team?
Yes.
Okay,
Yeah,
are you?
madam. Yes.
Yeah. This is the post. I'm not that sure because yesterday I saw there is a video here, but today I can't see. Do you see any video there? Our previous meeting video. Have you found in your page?
No, no.
No. Please check again because this morning the student from other class they can see the photo. The video, the previous video. From previous class. Hello class. No.
Wait, madam.
Mm.
Still checking.
If yes, then that will be good that you always, if you miss out, maybe because of a poor connection of my internet or your internet, you can always go to check back the one that you have missed out. Okay, let me know, okay, through the WhatsApp later if you need me to share you back the previous video, okay, and today's video, okay. So now I will show you my slides. I'm not going to be fully with you right now, okay? So can you take this problem down? By using the ODL, it will be very easy, right? Just to snap it. Have you done, everyone? This is a very, very quiet class, huh? Maybe I shall talk to some. Oh, this is a male more than female, huh? Class, huh? I want to talk to Najwa. Najwa? 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 Akila?
Yes.
Okay. So have you taken the slide, the tutorial just now? Have you seen my tutorial screen?
Yes, yes, yes. I've seen your tutorial.
So have you taken it down?
Yes.
Okay, fine. So now you need to work on this tutorial, the material that I have posted in the I discuss. Okay. So I think I will end the class right now. Okay, for you to work on your tutorial and also your exercises. Do you have any question for me?
No, no question.
Okay, no questions. Then you're given about an hour, okay, to do all your this tutorial and the exercises and post the discussion in the this U future. Okay, by at the end of the class later, I'm going to post you the answer for this problem, for this tutorial. Are you clear, everyone? Do you know what you are
Yes.
doing?
Thank you.
Okay, thank you. So we are going to meet again next week, right? Next Monday. But actually, I want to discuss with you on something. But our students here is getting lesser and lesser. Wait for a while. I'm not that sure. Since you are all around, may I ask your timetable? Okay. Wait. This, can you see my timetable?
Yes.
Yes.
Okay. So I'm asking whether you have any slots, available slot for me so that I can change this slot to before 4 o'clock. Okay. Do you have any uh, uh, are you all in the same class?
No.
No. So you have a different timetable?
Yes.
Yes.
That will be difficult. Okay. So these are my slots. Is the 2A have their own 2A class and the 2B has their own 2B class, is it?
No.
Mm,
Yes.
yes, it is.
Or within the 2A also have different classes?
No, no, no.
Okay, so may I just ask, I mean before we left, okay, so that we can further discuss later in the WhatsApp group. Okay, so any classes on Monday available from 2 to 4? This slot? 2A available or not?
No, no,
No,
No.
no, no.
November.
Okay, so cannot. So how about Wednesday, this slot?
No.
This is from 2B, 2A.
2A.
2A also no. How about this slot?
No.
No,
This is also from 2B, 2A.
2A.
2A also. Wow, 2A is all not free. How about in Tuesday? Any slots?
No, madam.
No at all. So full.
There are slots.
11 to 1.
11 to 1. How
Yes.
about
Tuesday.
how many hours in Tuesday that you need to go for 2A class?
4.
4.
4 hours. 2B class? 2B? Hello, 2B, other. We don't have anyone from 2B, is it?
They are shy.
They are shy. Because I have a problem if this, I have to get a big arrangement if this slot is to maintain. Okay, so I note that you have 11 to 1. Okay, if 2B also can make it. But how about your other slots, these 4 hours? Will it be difficult for you? If it is difficult, I will make my own arrangement. Or night class, it will be not preferable. Okay, so I will put this slot in the discussion. If still not, then I will do my arrangement for my own things on this. We will maintain here. Okay, so I will please go to the tutorial sessions and I will post you the answer soon. Okay, thank you for coming
Okay.
this class. Okay.
Thank you, madam.
Thank you, madam.
Thank you, madam.
Bye, madam.
Bye.
Stay safe.
Yeah, you too.
Thank you, madam.
Bye.